the reason it has a negative sign is because you input the future value and the present value have to be opposite signs. So in this case, I should have put in my present value as a negative $1.10 would get me back $5.92 later on. So present value and future value have to be opposite signs. You invest, so that's an outsource or a negative number, and you get back. If you're investing in stock, you put it in as a negative present value to get back a positive number in the future. Okay.
Could you walk through that one more time?
Of course.
Thanks.
So, yeah, because I messed up the interest, and now I've got to think about the interest again. Okay, so I'm going to get a dividend of $1.10 today, and that can you see the calculator right now?
Yes.
Yeah. Okay. So $1.10 is my present value, and present value is right here. The number of years that it's going to be investing for is 5, and that's my N. My interest rate is, I can never remember if it's point because you do it differently in Excel, is 0.4 is my IY, that's my interest rate. Payment says I pay the exact same amount every year. So at this point, we're putting in a 0 for payment, and then you hit compute your future value. Okay, it's 0.4. Sorry, I just messed you up. It's 0.4 goes in interest, and then I'm going to compute my future value. Nope, it's 40. Sorry. Let's see how often I use a calculator anymore. Yeah, it goes in as point. Okay, let me explain what I just did.
Okay, yeah, that.
Did you get it? Did I mess you up completely?
It messed me up because I put in the 0.4 too, and I got what you initially got.
Yeah.
So instead of the 0.4, it's 40.
It's 40, yeah.
Got it.
In Excel, you're putting it as a percentage. In here, you're putting it as the 40. Okay. All right, let me share now and come back over to this one. Okay, so now we want to know is how much would an investor have to set aside today in order to have $20,000 5 years from now if the current rate is 15%? So what do we know? So if we go back to our original formula, we know that the future value is 20,000, the N is 5, and the rate's 15%, and we're trying to figure out the present value. So when you have a present value, if you would raise your hand.
Carol, we can't see your other screen right now.
What are you seeing right now?
The calculator.
Oh, sorry.
I did get the number though.
You did? Okay, hold on. Let me pop the screen back up. Thanks for letting me know, Bruce. Are you seeing it now?
Yeah, I can see it.
Thanks. Did everybody get this 99.43.53? So what I would put in the calculator is my future value is 20,000. My N is 5. My rate is 15, not 0.15, 15. My payment is 0, and I'm computing present value. And the present value should come back as a negative number. So I invest 99.43 today in order to get $20,000 back in 5 years if I can earn 15% per year. And if you were using Excel, so in Excel, I know this sheet looks really busy, and it is, but we're going to go through each one of these problems. I don't remember where it is. 20,000. I had this all set up earlier. Let me see, where is it? Here it is. Okay. So we're working right here. So what I know is that my future value is 20,000. My payment is 0. My rate is 15%, and here it is as a 0.15, and my N is 5. And the formula I'm using is called a present value formula. And the formulas in Excel are right here under the formulas tab up at the top, and you would pull up the financial formulas. So the formula is E equals present value, and it tells you exactly what you need to do. The first thing you need to do is put in the rate, and the rate is 15%, comma, and then it wants to know the number of periods, 5, comma, then it wants to know the payment amount, 0, but we'll put it in anyway, comma, and then it wants to know the future value, and it's reminding you that the present value and future value are opposite signs. So I'm going to put in my future value is 20,000, knowing that I'm going to get out a present value that's opposite sign, comma, and then it asks for type, and the default for type is 0, which means that the payment occurs at the end of the period. So you typically don't need to put that in. You can put in a 0, but you can also skip that comma and just close the parentheses there. Ordinarily in finance, what we assume is that your payments occur at the end of the period. And we do that because it's a little bit more conservative. Time value of money, the further out the payment occurs, the more conservative that approximation is. And so we typically assume it's at the end of the period. And the only exception that we see, and we'll do some of these later, is things like if you go to rent an apartment, you have to put the first month's rent down, and then you start paying after that. That's called an annuity due, and the dollar amount is up front. And then that's the only time that we would be switching, is if payments occur at the beginning of the period instead of the end of the period, you'd have to make an adjustment here. But typically that doesn't hold true. So you see the formula is right here. The present value formula just asks you to put those exact same values in here. It's really a simple way to do the calculation using Excel. And we're going to see the formulas for all of the different calculations that we do using Excel. Okay, let me go back over to the PowerPoint now. Okay, what if we deposit $5,000 today into an account paying 10%? We want to know how long it takes to grow to $10,000. Brian, what does that $5,000 represent? Brian S.
Is that the present value?
That's the present value, good. And Michelle, what's the $10,000? I think Michelle's still having some trouble. John R., what's that $10,000?
Excuse me, sorry. I was eating a strawberry. 10,000 is future value.
Okay, and if I get back to the problem. Hold on, sorry, I flipped right away from that problem. There we go. And Brian R., what's that 10%?
That is your rate.
That's your rate. And what you're trying to find is your N here. Now, the only tricky part about this problem is to remember that we're depositing $5,000 today, so that's a negative number to get back a positive $10,000 in the future. And when you do that, let's see. Lindsay, what'd you get? It helps you if I call you by the right name. Cindy, what'd you get?
I'm still trying to get Excel to work, sorry.
Still working on it? Okay. Let's see. Josh, what'd you get?
I haven't gotten it yet either. I'm still working in Excel.
Is the formula the same for this too?
Yes, it is. Same formula. We use that formula for almost everything until we get to annuities. Ryan, what did you get?
Could you go back to the slide?
I'm trying to.
I'm still working on it as well.
Every time I try to move you guys, it jumps the slide around instead. Here we go. There you go.
Professor?
Yes.
In the formula for the number of years, do we just ignore that in the Excel formula?
No.
Or like
it's a slightly different formula. So let me pull up the formula so you can see what it looks like. Okay, if we're doing it on the calculator, let me pull up the calculator so you can see it. So in the calculator, what we're going to say, can you guys see the calculator right now?
Yes.
Okay. So in the calculator, we would be putting in, we're going to deposit 5,000 today. So that's going to go in as a negative present value. 10% is my interest rate. 10,000 is my future value. My payment is 0. And I'm going to compute the N. And the N is about 7.3 years. If I'm doing this in Excel, when I do this in Excel, here's my setup for it. My present value is a negative 5,000. My future value is 10,000. My rate is 10%, and I'm solving for N. And so the formula is for an N per. So I'm trying to find the number of periods is what that stands for. So the formula is equals N per parentheses, and now it wants the rate first, and then it wants the payment. I didn't put a payment number here, so you can just put in a 0. It wants the present value. You have to have the opposite signs for the present value and future values. Future value, and then the type again. We are assuming it's at the end of the period, so we don't have to put in a type. That's the default, and it gets to the about 7.3 years. This one is also known as the rule of 72, and if you're trying to double your money, so if you know your N. If you divide your N into 72, you get your rate. On the other hand, if you know your rate, you divide it into 72, you get your N. So if I knew that it was going to take me 8 years to go from 5,000 to 10,000, what would my rate of return be? Bruce?
You say Bruce?
Yeah, I said Bruce.
I missed that. So
okay.
What was the question again?
So if so, the rule of 72 says if I know my rate, I divide it into N I divide it into 72 to get the number of years it takes to double my money. If I know how long it's going to take to double my money, I can divide it into 72 to figure out what rate I'd be earning. So if I knew that if I deposited 5,000 today, I would have $10,000 in 8 years, what rate would I be earning?
Am I coming up with 14%, or am I wrong?
Yeah, no, that's not right.
Yeah, so 9%.
Okay. Okay. So if I know that it's going to take me 9 years to double my money. Okay. So if I know that it's I'm trying to find the rate, and I know it's going to take me 8 years to double my money, then if I solve it turns out that my rate is 9%. So that only works if you're doubling your money over something less than 12 years. But that rule of 72, you'll hear it referenced periodically, and that's all it means. But we could do that same problem using Excel or the calculator. So if I know that, let's see, that my money is doubling in 9 years, let me go back over to Excel so you can see that. So, and I don't even have to know how much I'm investing. So if I say my present value is 1,000 and my future value is 2,000 and my payment is 0 and my money is doubling in, N is 8. So what I'm trying to find here is a rate. And what I'm looking for is equals rate. And the rate wants to know the number of periods first, comma. It wants to know the payment amount, comma. It wants to know the present value. Oops, and I didn't put the present value in as a negative number, so I'm going to do that now. A negative present value. And it wants to know the future value. I don't have to worry about the type. But the only other thing you do differently with rate problems is you have to include a guess, and I always put in a 0.1. Rate problems are slightly different in that it's an iterative process and it's trying to iterate to figure out what rate it would be. So rate problems require you to put a guess in at the end. Only thing different from other problems that we looked at a few minutes ago. But you can see the rule of 72 holds. 8 times 9 is 72. The money doubled. We could change this to 4,000 growing to 8,000, and it's still going to come up with a 9%. So anything that doubles up till about 12%, the formula works just fine. All right, let's pop back over to the PowerPoint again. Okay, so now we want to know, the book will go through the process of using the formulas to find these numbers. And I used to teach the formulas. You had to remember natural logs and things. There's no need. You can use Excel. You can use the calculators. Nobody really does these natural log formulas any longer. So the formulas that the book has, it's not necessary to know. It's at least as appropriate to do these problems in Excel or on the calculator. Now, what if we know that we have a child going to college? It's going to cost $50,000 when they go 12 years from now. You have $5,000 to invest today. You're trying to find the rate. So again, this is a rate problem. On your calculator, you can go ahead and do this problem. Remember, you're going to invest $5,000 today, so that's a negative present value to bring in a future value, and you're solving for the rate. If you're doing this in Excel, remember you have to put in the guess at the end. So the formula is equals rate. And then at the end, it's going to ask you for a guess. I always put in 0.1 or 10%. So take a minute and work on this one, and then we'll check to see how you did. Okay, Lauren, what did you get?
I got 21%.
And what did you use, Excel or a calculator?
Excel.
Okay, so let's do the calculator example first. And so with the calculator, I'm going to hit clear. So I have $5,000 to invest today. And since I'm investing it today, that's an outflow from my pocket. So it's a negative present value. And I'm going to invest for 12 years. So I have an N of 12. I have a zero payment. And in the future, I'm going to have $50,000. I need $50,000. And so what I'm going to compute is what rate I need to earn. And rate is the same as IY. And so it comes up to be just over 21%. If I did it in Excel, where I put that rate one, let's see. 5,050, here it is. Okay, so in Excel, I'm putting a present value of 5,000, future value is 50,000, my N is 12, payment is 0, and there's my rate formula. The only thing funky about the rate formula is the beauty with Excel is it pops up everything that you need. N per is the number of periods is 12, payment is 0. And notice in this case, when I wrote it in Excel, I did 50,000 was the outflow I was going to need to pull out later. The present value is 5,000. I don't count off for signs. You just need to remember that they're in the opposite direction. Present value is 5,000. My future value is 50,000. Now, I need to put a 0 in here because it's looking for something before the guess. So put in your 0 for end of period. And then I just do a 0.1 and it will pop up at 21%. Now this only has 2 decimal places. I typically format the cells in Excel to have to go a couple of extra decimal places. This is a percentage cell so that I can see. You'll see as we start to get to bigger problems like calculating mortgages and things, as the problems get bigger, those decimals matter. So get in the habit of keeping your cells to several decimal places. It will just increase the accuracy of your numbers.
Quick question on that, Professor.
Yes.
Do you actually have to put in a guess on there or a type? I know I just did it on mine and I didn't have to put it in. It still calcs the same.
You did a rate in Excel and it worked properly?
Without putting in a type or a guess. Yeah, I just
Okay.
put in the N per payment, PV and FV.
Yeah, the problem, Kyle, is we're going to get to internal rate of return in a couple of weeks. And when you do internal rate of return, there are times when you could get 2 different internal rates of return. And if you don't put in a guess, you're going to get an incorrect answer. So it's more the discipline of doing it now because it's going to matter later on.
Gotcha. Sounds good.
Okay.
Question?
Yes, go ahead, Janet.
Sorry. You put a 0 before the guess. I did it without it and I got the same number. What does that 0 for type mean?
It means that the payment is occurring at the end of the period. Excel typically knows that if there's nothing there, it's a 0. So ordinarily you're fine. The discipline of putting it in when you're doing a rate is a good idea because we're going to need that when we get to IRR later.
Okay, thank you.
Okay. Before I move on, how are we doing at this point? We ready for another example, or are you feeling like that's about enough to absorb for one night? Raise your hand. Yeah, go ahead.
I had one question. The putting in the guess, that's when you're using Excel, not the calculator?
That's correct. The calculator does not require a guess.
Right, okay. I didn't think so. Thanks.
Just Excel.
Is the present value always going to be a negative in these calculations?
The present value and future value are always opposite signs. That's what matters. I like thinking about one is the outflow from my hands, the other is the inflow coming back in. So it depends on what direction you're looking at the problem. Where we run into trouble later is we do bond problems. And with bond problems, we start to have payments as well as future values. And then payments and future values always have to be the same sign. So the reason you'll often see me do a present value as a negative is to remember that in the future, payments and future values have to be the same sign. And it's the opposite sign of present value. So I most commonly put in present value as a negative number and expect future value to be positive, just because that's the way it works with bonds later. And that reminds me that the interest payments are also going to be a positive.
Okay, thank you.
Okay. Tim, did you have something you wanted to? Oh, that was Tim, sorry. Anybody else have any questions before we look at one last problem? We'll do one more and then we'll stop for the evening. Okay, again, when you look at the book, they go through the formulas using solving for an exponent and such. Yeah, I mean, I taught that 20 some years ago. Since Excel and really as calculators have gotten better, we don't use these formulas anymore. But if you're going through the chapter and you see the formulas, this is what they're doing, but your calculator in Excel is doing the same thing, much, much simpler. All right. What if we have an investment that's going to pay $200 1 year from now, and your cash is going to increase each year by $200 through year 4? Your rate's 12%, and you're going to pay $1,500. This is a good investment. We're not going to do this whole problem, but I want to set it up because I want you to see the practice of doing cash flows. So what I want you to start doing is setting up timelines. It reminds you when the cash flows occur. And we're going to see later as we start doing some dividend problems for when stocks are paying dividends. You have companies like Amazon that pay no dividends for a while, and then they start paying dividends, and you're trying to value what you would pay for a share of Amazon today. Setting things up on timelines become really important. Excel lets you do that really nice and easily, but using an actual timeline is a good idea. So the first payment I'm going to receive is $200 a year from now. $200 a year from now, and it's going to grow by 200. So the next year it's going to be worth 400. The next year it's going to be worth 600. And the following year it's worth 800. And then the payments stop. And I want to know how much this is worth to me today if my investment is earning 12%. So what you're doing here is a series of present value problems. So 200 is the future value. Discount it at 12% for 1 year, and 400 is the future value. Discount it at 12% for 2 years. 600 is the future value. Discount it at 12% for 3 years, and 800 is the future value. Discount it at 12% for 4 years. And then you add those together, and that's the value of your investment. We're going to stop there for now, because I'm going to show you how to do this on the calculator and in Excel next time. It's a little bit more involved than what I was expecting given how late it is this evening. But we'll start here. But you should all be able to look at this problem and go through and find these numbers. You should be able to find those present values and then add them together to make sure you're coming up with this 1432. Okay, so finish up go through and look at your financial detective again, finish up this problem, and we'll start right here next time with working out this problem. Pop back over so I can see you all. Any questions before we finish up for the night?
Professor, are we on track for our test being the same date?
Oh yeah, I never changed the date of the test.
Oh, good. Okay.
The date is set because you have other tests and things, so I don't change the date. How much content goes in varies depending on how much material we cover. So I don't rush to make sure we get that content. I make sure that the date stays the same and the content.
Great. Thank you.
Content adjusts. Okay. Any other questions before we end for the night?
Dr. Lego, I have a strange question.
Yeah.
When you go over to the slides, to your PowerPoint,
Uh-huh.
I can't reduce, I'm looking at how I can reduce the screen so I can go to Excel. Like right now I can reach up and I can do that.
So when I'm sharing, you can't get into anything else?
I don't have any way of reducing that, so I could, yeah, that's exactly right.
So you can't minimize your Zoom?
That I can probably do. I'm sorry, I know what you're saying.
I think you should be able to minimize Zoom and put Excel in the background. Is that right, everybody? Because I see things a little bit differently than you do. I think
if it goes to full screen, just press escape and it'll take it out of full screen, and then you should see your minimize and buttons and whatnot.
Perfect. Thank you.
Okay.
Appreciate the help.
Everybody good for the evening? Okay, if it's still icy, be careful driving. Have a good evening, and I'll see you right back here next week, and let's see what happens to the markets between now and then. Have a good week, everybody.
Good night, Prof.
Good night. Have a good week.
Have a good night.
Good night, everybody.
Bye, everybody.
Bye.